A very good morning, students. Welcome to the lecture series on operating systems. In this session, we are going to discuss about process control block and process states also. Coming to the process, what is a process? Before getting into the understanding of a process, everybody need to understand about a program. What is a program? Program means a set of instructions. A set of instructions is referred as a program. Like we are writing a hello world program. What is the meaning of the hello world program? Like we are giving some input, then the machine is going to process it and going to display some output to the user. So consideration of the input and allocation of the memory required and allocation of the CPU, further the displaying of the output to the user, all these tasks are going to be considered as a program. In this process, a program under execution is referred as a process. Means when the user is writing like an instruction, then it is referred as a program. Once it is getting executed, some exe file will be generated, right? So the process is referred as a program under execution. So the set of all instructions which are being written by the user, the set of instructions are a segment of code. What it is referred as? It's not a process, it is a program. So when any of the program which have been allotted with the CPU, then it is referred as process. Means a program under execution is called as a process. Thereafter, when a program can be transformed as a process. If a program has been transformed as a process, once it has been loaded into the main memory. Once a program has been loaded into the main memory, then it is ready to execute. Thereafter, it will be transformed itself as a process. And then, a program is a passive entity. Means there is no requirement of memory allocation, there is no need of CPU allocation. Likewise, it is referred as a passive entity. And then process is referred as an active entity because the required CPU devices allocation, the required IO devices allocation, the required memory allocation, all these things are being done only if it is transformed as a process. So it is referred as an active entity. A program can be referred as a process only if the executable file is loaded into the memory. Every program can be converted as an process only once the executable file is loaded into the memory. Means for example, you are very much interested to browse. Then the Firefox or Internet Explorer files are supposed to be loaded into the main memory and then only it is referred as a process. Means once the .exe files or executable files are loaded into the main memory, then only it will be treated as a process. The execution of the program has been started through GUI mouse clicks and command line instructions like debugging or execution of a program or compiling, whatnot. Whatever you are doing, all these things are being done through either keyboard or through mouse clicks, right? So the GUI mouse clicks and command line instructions are basically meant to convert a program as a process. In the case of the process, a program can be managed by many number of the users simultaneously, and it has 4 sections. What are those 4 sections? The first section is stack, then heap, text and the data. These are the 4 different sections are there in the case of the process. What are those 4 sections? Stack, heap, text and data. Thereafter, let us discuss about individual subsections. Coming to the first one, stack. What is a stack? Stack is used to load the temporary information related to a program, like the functional arguments and then the input arguments, output arguments, the return address, likewise whatnot, which are related as a temporary data. All that temporary data will be held in the stack. During the execution, some of the times the dynamic memory allocation requirement will be there. All that dynamic memory allocated data will be available in the heap. So the memory allocation, dynamic memory allocation will be carried through heap, and if any of the process which needs the temporary information, all that temporary information will be available in the stack. And then text. Text is used to describe the current activity and program counter information. What is a program counter? Program counter includes the instructions which are going to be executed very next. So the next upcoming activity and current activity informations will be described by the text. And finally we have a data. This section is going to hold global and local variables which are being executed, which are being required in the execution of a process. All these informations were available related to the process. So process consists of 4 different kinds of subsections. The subsection 1 is going to consisting of the stack. Stack is used to hold the temporary information such as input arguments, output arguments, and other written addresses like. And then heap. Heap is used to hold the dynamic memory allocation which is required for the execution of a process by the CPU. And then text. Coming to the text. Text holds the current activity and as well as whatever the next activity is going to be executed. That means the information available in the program counter. All these things will be available in the text. And finally, the global and local variable information will be available in the data segment. So now let us discuss about process state diagram. This process state diagram comprises of 5 different states. Those are new state, ready state, running state, waiting state, and finally exit state. How a process will undergo each of these states, and then when these particular state transition will be carried, and all these things are going to be discussed in this particular session. Now, a program has been just executed, and executed in the sense a program has been loaded. Where it was loaded? Into the main memory. If any of the program which was loaded into the main memory, then what do we call it as? It is referred as a process. It is referred as a process. So the program was loaded into the main memory. Now onwards we are going to call them as a process. Okay, first of all, we are going to talk about new state. What is a new state? If a program has been just created, then it is referred as a, then it is described as a program and a new state. What is the meaning of a new state? A program has been just created and some instructions were given, but it was not yet loaded into the main memory. Students, please remember that. Now onwards, we are going to load the process into the main memory. Now onwards, the process is currently available in the disk storage only. Okay, so a program is in new state. A program is in new state until it has been, until it is loaded into main memory. So if any of the program has been loaded into the main memory, then the state transition will be there. Now we have just created a program and we have written some instructions in it. Likewise, we have created a sample program.c. In that you have written some instructions like library inclusion and then some instructions, memory allocation, and finally the output what you are supposed to print. Likewise, whatever the instructions are there, all those instructions have been written by you. Now onwards, we are going to load that program into the main memory. Once the program has been admitted into the main memory, then it is ready for execution. Now the program is considered as process. Now the program is going to be considered as a process and it is waiting for CPU. So until the allocation of the CPU to a program process, it will be in a ready state only. Until the allocation of the CPU to a process, it will be in a ready state only. Once after scheduler has been dispatched. What is the meaning of the scheduler dispatch? Let us talk about the schedulers in coming sessions. But once the scheduler has dispatched the process, and then if it is And if it is allocated with the CPU, then it will getting into the running state. What is the meaning of the running state? It is allocated with the CPU. Allocated with the CPU, and it is currently in the execution. Then it will be in a running state. During the execution at the running state, some of the times it doesn't require any of the IO devices. So it will complete its execution and then move out of the main memory. That is referred as exiting. That is referred as exit state. Once after the completion of the execution of a process, it will move out of the main memory and it completes the execution. Then it will be in the exit state. During the process execution, some of the times a process may also require some IO devices. If any of the process which needs some IO devices, then it will get into waiting state. What is the meaning of the waiting state? During the process of execution, some of the times the process needs some IO devices. If any of the IO device is required, then the process will move from running state to waiting state. Once after the allocation of the required IO devices, then the process will again come back to the state called ready state. So, firstly, a program is there, a program is just created, then it will be in the new state. Thereafter, it has been loaded into the main memory. If it is loaded into the main memory, then it will be in the ready state. And then scheduler has assigned its CPU to it. Once assigned CPU is assigned to it, then it will be in the running state. And then if it doesn't require any of the IO devices, then it will exit from the main memory. Otherwise, in some of the scenarios, if any of the process which needs IO devices, then it will coming into the waiting state. After the allocation of the required IO devices, then again it will get back to the ready state. As usual, after some time it will get the CPU, then it will execute and finally left from the main memory. Okay students, hope you are very much clear about the process state diagram. If any of the process is just created, then what is its state? New state. If it is waiting for the CPU, then what did it say? Ready state. If it is currently executing, what is the state? Running state. If it has completed the execution but doesn't require any of the IO devices, then what is state? Exit state. If any of the process is waiting for the IO devices, then what is state? Waiting state. If the required IO devices have been allocated, then what is state? Ready state. Okay, hope you are very much clear about all the possible states. And then now we are going to discuss about process control block. There is another important point I have miswritten it, that is interrupt. In time sharing machines, the CPU will be allocated for a small amount of the time, very small amount of the time, like 1 millisecond or 10 milliseconds. Likewise, we will allocate the CPU for a short interval of the time. After the completion of the short interval of the time, the process will be switched from running state to ready state. This is called interrupt. What is an interrupt? In the time sharing machines, after the completion of the time slice or time interval or quantum of the time, these are all similar words, synonyms. Okay, after the completion of the time slice, the process will be moved from running state to ready state, and it will be done through an interrupt. So interrupt based transition is referred like, after the completion of the time slice, you please remember one point, it is time slice is expired, the process execution is not yet completed. So if the time slice has been completed, then automatically the process will be moved from running state to ready state. This is called interrupt based transition, and let us have the further discussion about this interrupt based transitions in the coming class. Okay students, now we are going to discuss about process control block. What is a process control block? A process in the view of the operating system. A process in the view of operating system is called process control block, simply PCB. If you are there in your home, you may be child. If you are there in the college, then you will be considered as a student. After marriage, you are going to be considered as a father. Likewise, you are a human being and you are changing your roles. Likewise, if any of the program is there, means a set of instructions are there, then it is referred as a program. Once it is loaded into the main memory and it is executing, then it is referred as a process. Likewise, the same process is going to be viewed like a process control block in the view of an operating system. Okay, in the view of an operating system, every process is going to be considered like a process control block. And this process control block consisting of various informations. What are those? One is, every process will have an ID. Every student will have an ID, right? Likewise, even in the computing machines also, every process will have some IDs. Those are referred as process IDs. And then, in the last slide, we have discussed about the state information like ready state, running state, waiting state. Likewise, every process will have a specific state information also. And then, some of the process requires some I/O devices also. So, device information. Required device information. Every process needs some CPU cycles, right? So that is referred as CPU cycle information. Likewise, some of the process needs some space to load into the memory. So the required number of memory cycles is also another information related to the process control block. All these informations will be stored in the name of process control block in the computing machine. Okay, so what are the informations related to the process in the case of the operating system? One is process ID, second one process state information and CPU cycles information, CPU registers information, file system information, memory management information. Likewise, the set of all information which are related to the process in the view of an operating system will be held in the term of process control block. Okay students, let us have a discussion about individual component in the process control block now. As I earlier said, the first thing is process state. In just last class, we just discussed about if a process is just created, then it is in a new state and it has been admitted into main memory. Then it is in a ready state and it is allocated with the CPU. Then it is in a running state and some I/O devices are required. Then it is getting into waiting state. After the allocation of the I/O devices, it is getting into ready state. After some time, the execution completes and it will get into exit state. All such a state information will be available in a process state. And then program counter. This program counter is going to hold what is the next instruction going to be executed. And then CPU registers. Whatever the information which is required for the execution of the process, all that information will be loaded into the memory in the terms of heap, which is already discussed in the last session itself. So that information will be loaded in the CPU registers. And then CPU scheduling information, what process is required to be executed, whether it is a low priority job or a high priority job. Likewise, the priority information and CPU burst information, whatnot, all these things will be available in the CPU scheduling information. And then if for the execution of a process, some of the local variables, some of the global variables, and those global variables and local variables are stored at some particular registers, and what is the particular memory address. Likewise, all the memory related information will be held at one segment called memory management information. And then accounting information. Coming to the accounting information, during the process of execution, as I earlier said, during the process of execution, some of the process needs I/O devices. During the process of execution, if any of the process needs I/O devices, then it will getting back into the waiting state. The required I/O device information will be described in the accounting information. And further, I/O status information. What is I/O status information? As I earlier said, if any of the process needs some I/O devices, but which are held by some other process, means which are not currently available, right? So, such a status information, I/O device related status information will be held at the I/O status information. Okay students, hope you are very much clear about all these particular segments of the process control block. What is the first one? Process state. In this process state, what is the current state of the process? Whether it is in running state or a ready state or in a waiting state. Likewise, the state information will be made available through process state. And what is the next instruction going to be executed is described through program counter. CPU registers which are required to describe the process related information which is essential for the execution and which is available in the different CPU registers, and the CPU scheduling information, whether the process is a high priority job, low priority job, or how much of CPU burst time is required for it. Likewise, the entire information related to the priority and as well as the CPU will be made available in the CPU scheduling information. And then memory management information. As a part of this, we are going to describe what is the starting address, what is the entering address of the instruction, and then where the particular informations are available, what is the particular address of them. All that memory related information will be made available to the operating system in the memory management information. Finally, accounting information and IO status informations. Accounting information means how many of the IO devices are required, how many of them have been allocated, how many of them are not yet available, and all such an IO related information is made available in the case of the accounting information. Finally, IO status information. It needs some printers, but printers are not yet available. Means the printer required information is available, and whenever the printers are made available, then automatically the process will get those IO devices. Likewise, the current status of the IO devices is made available in the view of IO status information. Okay students, hope you are very much clear about what is a process. A program under execution is called as a process. What is a program? The set of instructions is called as a program. When a program will be converted as a process, if a program has been loaded into the main memory, then it will be treated as a process. Otherwise, if any of the program whose executable file is loaded into the main memory, then it is called as a process. What a process will be called in the view of an operating system? Process control block. And what are the different components of the process control block? Process state information, process control block related information includes CPU related information, memory management related information, accounting information, status information. Likewise, all these are part of the process control block. Thank you students.